Welcome, welcome. This is Chapter 4, Section 5, Logarithmic Properties. So the first property that we are going to examine is the product rule for logarithms. Now, if you are interested in the how, that would be all of this. All of this. So you're more than welcome to pause the video and read that if you would like. So one thing I would like to just generally cover is what the product rule actually is. So the product rule for logarithms says that if whatever is on the inside is the product of two things, then that logarithm is equal to the logarithms of those two things added together. So what you would do is you would factor everything if you can, and then you would use the product rule for logarithms, this little identity here. Remember, b's got to be greater than 0. So notice here they did log 3, and then they had already factored things. So here m is equal to 30x, and n is equal to 3x plus 4. So that's what they have. And now notice you can keep breaking this up until it is in completely prime logs. So that would give me log 30x, remember base 3, plus log base 3, 3x plus 4. Now we can't factor anything else out of 3x plus 4, but we can turn 30 is 5 times 6, so if we keep going we can do log 3, 5 plus log 3, 6x, and we'll put the x with that 6. Log base 3, 3x plus 4. Now here, 6 is 2 and 3, so we can break this up. It can be log 3, 5 plus log base 3, 2 plus log base 3, 3 plus, and notice how the x is also multiplied, so that means we can pull that one out on our own, plus log 3, 3x plus 4. So let's try to expand 8k. So what does 8k look like completely factored? Well, it's 4 times 2 times k, which is 2 times 2 for 4 times 2 times k. So it will look like, and it's log base b, so it will be log b 2 plus log b 2 plus log b 2 plus log b k. And this is what it would look like completely expanded. Now another rule we're going to have a look at is the quotient rule. So the quotient rule is what happens if we have values on the inside that you can form into a fraction. So what we're going to do is we're going to subtract them from each other instead of adding them. And here is the example that your book has. I am going to go ahead and go over this one. So the first thing I'm going to do is I'm going to see if I can factor the inside right here. So that's going to give me 7x x plus 3. And that gives me over 7x x minus 1, x minus 2. And you may be asking, hey, is it okay if I cancel those factors? Well, we're going to find out right now. So this is my top, and this is my bottom. So remember, it's going to be log m, which is log base 3, 7x times x plus 3 minus log base 3, I'm going to scoot over for this one, 7x times x minus 1 times x minus 2. So now I can break these up according to the product rule. So I'm going to get log 3, 7x plus log 3, x plus 3 minus log 3, and I'll do this one in parentheses to show you what's going on. So minus, and then I'm going to break up this whole log. Log 3, 7x plus log 3, x minus 1 plus log 3, x minus 2. So now I would distribute the negative. So we would have log 3, and 7x, it looks like it can be broken up again into log 3, 7 plus log 3 x, and then we have log base 3 x plus 3, and then we have, we're going to break this log 7 up into log 3, 7 plus log base 3 x, and I'll just distribute the negative to those. So minus log 3, 7 minus log 3 x minus log base 3 x minus 1 minus log base 3 x minus 2. Okay. So when we rearrange those, notice that we have a positive log base 3, 7 and a negative log base 3, 7. We have a positive log base 3x and a negative log base 3x. So those will cancel, and they'll go away completely. And also, back to here, the question we had earlier, you could cancel those, because when you do it all the way out, you'll notice that they do cancel anyways. So if you wanted to save time. So that gives us log 3 x plus 3 minus log 3 x minus 1 minus log 3 x minus 2. Okay, so now let's say that I give you this, and I want you to condense it, to put it back into one logarithm. Well, you have a subtraction here and a subtraction here. So you should notice that subtractions would be the quotient rule. So one thing I could do is I can start here with log base 3, and then I know since this one is addition, it's positive, it will be on the top, and then I know I have a subtraction here, so it will be x minus 1. And then I will have minus log 3 x minus 2, and again I can do the quotient rule, and this says I will have x plus 3 divided by x minus 1 divided by x minus 2. So we would be able to just multiply the bottom by x minus 2, which gives us log 3 x plus 3 x minus 1 x minus 2. Notice that that's our original log with that factor of 7x canceled. Now with it being canceled, there would be no way for us to determine that factor of 7x existed unless I gave you the original log. But that's okay because it canceled out in the original, so this kind of is, you know, the original with all common factors removed. So another interesting one is the power rule. And that will allow you to take exponents, here it is, on the inside and turn them into multiplication on the outside. So notice that here they just brought that 5 straight down and multiplied it. So that means if you were to have ln x squared, you would have 2 ln x. It'll just go right in front. Here, notice that it originally does not look like we're given an exponent, but 25 is actually 5 squared. So this is the same thing as 2 times log base 3 of 5. So we'll do this ln 1. Okay, and remember the properties of exponents say that if I want to bring that up top, it becomes a negative, which gives me minus 2 ln x. Now let's say you wanted to use the quotient rule. You would get ln 1 minus ln x squared. Remember, ln of 1 is 0. Minus, using the power rule, 2 ln x minus 2 ln x. And that is the same answer that we got above. And this is an L. Guess I'll write them like that so that they don't look like ones. Okay, so the reverse power rule is the same like what we did for the quotient, and you can also do it for the multiplication rule. So here we have 2, that looks like a 1, I'm sorry. We have 2 log 3, 4. Okay, so if I wanted to reverse this, it would be log 3, 4 squared. Okay, so let's practice all of these together. So here is the books example. It's a nice example. And we will go over this number 6 one. So we're going to expand this. So what I know is we are first going to have, I can use the quotient rule, and we can have x squared y3 minus log z to the 4th. And then that's going to give us, breaking these up again, log x squared plus log y to the 3rd minus log z4. And here I used the product rule, that multiplication one. Now I'm going to use the power rule. So I get 2 log x plus 3 log y minus 4 log z. That is everything all broken down. All right, now we're going to have a look at this one. This is the book's example. It's a good example, you know, have a look. But we're going to expand ln cube root of x squared. So this is going to be ln, and remember a cube root is just that whole thing multiplied by that fraction with whatever number you need on bottom. And I can just multiply those exponents. So I'm going to have ln x 2/3. And that's going to give me 2/3 ln x. Notice you cannot expand anything with a sum or difference inside. That's where you have to stop. So if I had, let's say I had ln cube root of x plus y, then that would be ln x plus y 1/3. Now here, since I do have something operating on the parentheses and those together, I can bring that 1/3 out. But when I get down to just addition or subtraction, I can't do that anymore. So this is where we would stop here. So here's a good one. Okay, we're going to expand this. So first, I am going to ln, I'm going to rewrite these using the quotient rule. Plus 1 squared minus ln x squared minus 9. So I'm just going to keep going. So I'm going to take this square root and make it to the everything to the power of half. X minus 1, 2x plus 1, 2 to the half. And that is going to be ln, this is x minus 3, x plus 3. Remember there's a formula for that. We went over it quite a couple classes ago. It was x squared minus b squared is x minus b, x plus b. And notice that 9 here is actually 3 squared. That's where I'm getting that. So now I'm going to raise everything in here to half. Notice that when I raise 2x plus 1 to half, I multiply 2 by half, so I just get 1. And then I can break these up here into ln x minus 3 plus ln x plus 3. Now I can break these up here into ln x minus 1 x minus 1 to the half plus ln 2x plus 1. And that's a plus. I can't go any further with that one. And I'm going to distribute this negative. And I now can bring down this half. So it's half ln x minus 1 plus ln 2x plus 1 minus ln x minus 3 minus ln x plus 3. And that would be completely expanded. So now we can work on condensing. So that's going the other way. Condensing will make it smaller. So the first thing we're going to apply is power. So next you will apply product, and then you will apply quotient, PPQ. Power product quotient. Power product quotient. Okay, here's the book's example. Let's go ahead and go over this one. So the first thing is power. I don't see any power things here. I don't see anything out front. Next, it is the product. So I have got log 3 minus log 4 plus log 5 minus log 6. So that's going to be, these will end up being multiplied. So we will have, I'm going to now identify the quotient. These are quotients. So I'm going to have log 3 divided by 4 plus log 5 divided by 6. And that's going to give me log 3 divided by 4 times 5 divided by 6. And now we can simplify those. So that gives me log, this is 2 times 3, so these 3's will cancel. So that gives me 5 over 4 times 2, that's 8. So we get log 5 over 8. Okay. So now we will try, okay. So now we are going to go ahead and try this one. So I'm going to have a look, and I see that I do have some power properties. So I'm going to go ahead with log 5 plus 0.5. I'm going to do that as half. Log x half, because that's a square root, minus log 7x minus 1 plus log x minus 1 cubed. So now what? I know these are multiplied, so it's going to be log 5, and I'll go ahead and make that a square root, minus log 7x minus 1, x minus 1 to the third. Now I'm going to do the quotient property. Remember, it's PPQ. And I'm going to say it is log quotient, that is right. It is log 7x minus 1 times x minus 1 cubed divided by 5 square root x. And this is what it is all, the whole thing. Not too bad. Okay, so let's see. Now we're going to work on this one. Well, I noticed that it has another set of parentheses and that there's a 4 on the outside. So I'm going to try to simplify the inside of the parentheses first, And we're going to start with power rules. So that's 4 log x cubed, because it has a 3 in front, plus log x plus 5 minus log 2x plus 3. Okay, so now I'm going to condense even further, and I add the first two together because I need the product rule now. So that means I can just multiply these together within one log, minus log 2x plus 3. There we go. Now I have the minus, and I can just turn them into a fraction here using the quotient rule. And then what I can do is I can deal with that 4 on the outside. And that's going to be x cubed, x plus 5, divided by 2x plus 3, the whole thing to the 4th. And that's how that's dealt with. Okay, so applying the laws of logs. So we're going to do pH here. That's equal to negative log the number of hydrogen ions. So it wants to know if, or we'll do number 2. It wants to know how does the pH change when the concentration of positive hydrogen ions is decreased by half. So we're going to set up our pH equals negative log. Our new concentration, we will call that, here they use C, we'll go ahead and stay with C. If it is cut in half, decreased by half. So here you can see they rearranged it to show you how it changed. So now we are going to solve for these values. So pH equals, and this is the multiplication property, that's negative log half minus, because it was a positive but now it switches to a negative because the whole thing's negative, log C. So now the original pH, they're calling it P, is equal to negative log C. So it's going to be pH is equal to P minus log half. And you could certainly break this up again, but they were wondering what that would look like. And so you would, of course, translate this into an answer similar to this. All right, that makes about 30 minutes, so I will see you in the next one.